All right, on page 818 today. Going to be working with areas of similar figures. Area of similar figures. And theorem 1.1 or 11.1 states that if two polygons are similar, then their areas are proportional to the square of the scale factor between them. All right, and the example is if you've got two shapes, they've got two polygons there. Polygon ABCD. And this polygon is blue. And then they've got the bigger polygon. And it is FGHJ. And that one's a green one. Or you can just put a G in there. This one's blue. This one's green. What they're saying is, and then they went and switched the order, but area of green over area of blue, meaning the area of the green quadrilateral over the area of the blue quadrilateral, is equal to one side over the green, which is FG, use that top piece right here, over AB squared. Because if you remember back to scale factor, that is the ratio of corresponding sides similar polygons. In simplest form. So when we take FG, this top piece, and we put it over AB, and we're told that these two shapes are similar, then FG over AB is the scale factor of the two shapes. All right, now it doesn't have to be FG over AB. It could be GH over BC. It could be JH over DC. Or it can be FJ or JF over AD or DA. It doesn't have to be those specific sides, it just has to be corresponding sides. All right, so the area of one shape over the area of the other shape is equal to the scale factor of the two shapes squared. So in the first part of the assignment today, you're going to use this formula to find the area, to find the area of one of the shapes. And then in the second part of the assignment today, you're going to use this formula to find the scale factor of the two shapes. And once you find the scale factor, you can find the measurement of a missing side. All right, so let's look at the example 1 down there. Find area of similar polygons. And you're told that JKL is similar to PQR. The area of JKL is 30. Find the area of PQR. That's what you're trying to find. So you've got the one shape kind of turned up this way. This is JKL. And it's 12. This side JK is 12. And then your other shape is rotated and bigger. PQR. This side PQ is 15. So here's how this is going to work. JKL, this is the shape on the left. All right. And this is, I'm going to put a 30 in here. The area is 30. The area of the bigger shape is what we're trying to find. So the formula that we just wrote down said that the area of one shape over the area of the other shape. Now, we did this earlier in the year. If this is the blue shape and this is the green shape, it doesn't matter how we write our first ratio as long as we write the second ratio the same way. Here's what I mean. I mean that if we say 30 over A, which is blue over green, area of the blue is 30 over area of the green, which is what we're trying to find, is equal to scale factor, the scale factor squared. So our scale factor here is going to be this side JK over this long side PQ. But if our first ratio was blue over green, then our second ratio needs to be blue over green again. I'm going to use the 12 in the numerator and the 15 in the denominator, and that's got to be squared. All right, everybody okay with that? Now, we can take this 12 over 15 and simplify it because they're both divisible by 3, aren't they? So I'm going to rewrite this as 30 over A is equal to 3 goes into 12 4 times, and it goes into 15 5 times squared. So now we're going to finish this, and we're going to solve for A. So 30 over A is equal to 4 squared is 16, and 5 squared is 25. All right, I'm running out of room, so I'm going to work to the left. So I'm going to crisscross multiply. So A times 16 is 16A, and that's equal to 30 times 25. And my calculator. $30 times 25 is 750. Going to divide both sides by 16. And the area of the bigger shape is equal to 750 divided by 16. 46.9. Questions? Okay, so area of one shape over the area of another shape is equal to the scale factor squared. Make sure you put your scale factor in simplest form. And remember that anytime you square a fraction, that means you need to square the numerator and the denominator. When you square a fraction, you have to square the numerator and the denominator. So let's do one more of those. Let's look at the top of page 819. On top of page 819, we've got a rectangle here and a smaller rectangle next to it. We got a side that's 8 and a side that's 5. We're told the area of the one on the left equals 32. For each pair of similar figures, find the area of the green. All right, so this is our blue, and this is our green. So we need this area on the right. Same process. We're going to take 32 and put it over A, right? Area of blue over area of green. So 32 over A equals, look at our scale factor, 8 over 5. Our scale factor equals 8 over 5. Can that be simplified? There's nothing that goes into 8 and 5 evenly, right? So we have to use the 8 over 5. So equals 8 over 5 squared. So our 32 over A equals 8 squared is 64 and 5 squared is 25. Gonna crisscross multiply again. So 64A is equal to 32 times 25. 800. Divide both sides by 64. And the area of the green is equal to 12.5. All right, and if this first area was in square centimeters, then the second area is in square centimeters. Good with that? Okay. Now, in example number 2, take a look at example 2. Using areas of similar figures. Now we're going to use the areas to find the scale factor, and then we're going to use the scale factor to find missing side lengths. So here's what we've got. We've got a couple of quadrilaterals again. You're told they're similar. We've got blue on the left and green on the right. The area of ABCD is 150. So this area is 150. The area of FGHJ is 54. blue one, 54. If the shapes are similar, find the scale factor of blue. All right, so they're asking you find the scale factor. Now pay attention to this part of the question. Pay attention to the order. The blue shape is F, G, H, J. The green shape is A, B, C, D. Find the scale factor of, they're not calling it blue to green, they're calling it F, G, H, J to A, B, C, D. Okay, that means that numerator needs to be blue. So what I'm going to say here is find the scale factor of, they're calling it F, F, G, H, F, G, H, J to A, B, C, D. When you're doing it, I would say find scale factor of blue to green. Blue to green. Blue to green means blue goes in the numerator, green goes in the denominator. All right? So the first thing they're asking you to do is to find the scale factor. So here's how we're going to find the scale factor. We're going to put area of blue, 54, over area of green, 150. We're going to set that equal to the scale factor, or in this case, we're going to call the scale factor K squared. Now, what goes into, or does anything go into 54 and 150 so that we can simplify? All right, so in this case, let's see, 150 divided by 6. Yeah. 6 goes into both of these. So look what happens. If we divide the numerator by 6, 6 goes into 54 9 times, and 6 goes into 150 25 times. And that's equal to K squared. So if we find the square root of both sides, then the square root of 9/25 is equal to K. Well, when you find square roots of a fraction, you find square root of the numerator. So the square root of 9 is 3. The square root of 25 is 5. And that's equal to the square root of K squared, which is K. So our scale factor is 3 to 5. All right? So that's the first part of the question. Find the scale factor. Our scale factor is 3 to 5. It says, and the value of x. So look, this piece was the x, and this piece was 10. So if our scale factor, blue to green, is 3 to 5, and we need to find this x right here, we're just going to write a proportion. So our x over 10, our blue side over our green side, x over 10, is equal to our scale factor, blue to green, which is 3 to 5. If we crisscross multiply, then 5 times x is 5x. 10 times 3 is 30. And divide both sides by 5. So our x is equal to 6. Everybody okay with that? Area of blue over area of green equals scale factor squared. find the scale factor. Use the scale factor to find the missing side. All right, so let's do one more. I'm going to do on page 819, I'm doing down on the bottom right, example 2b. Got a couple diamonds there, or kites. So here's one kite, here's other kite. Now here's our blue. This one's our green. We've got a side that's 40, a side that is X. We got an area that's 400, and an area that's 64. First thing we're going to do is find the scale factor. Find the scale factor of blue to green, then find X. So blue to green again, so that means blue is in the numerator. So we're going to say 400 over 64 equals k squared, k being the scale factor. Now, if you're not good at simplifying fractions, okay, take 400 and divide it by 64. Maybe you shouldn't do that. Let's not do that. Let's simplify this first, the 400 over 64. And before I wrote it up there in the formula, I could have written it down here, 400 over 64. 64 is a perfect square, and it's divisible by, its square root is 8, and the square root of 400 is equal to 20. But let's do this. They're both even, right? So we can simplify this to 200 over 32. They're still both even, so it simplifies to 100 over 16. Those are still even. We can go 50 to 8. Those are still even. We can go 25 to 4. That's simplifying 400 over 64 as everybody in this class can do. We started off with two even numbers. We just start halving them. So we're going to rewrite this 400 over 64. I'm going to erase it so I don't run out of room. The ratio of our areas can be rewritten as 25 over 4. So if we square root both sides here, the square root of 25 is 5, and the square root of 4 is 2, and that's equal to k. So our scale factor is 5 to 2. So now we're going to go blue over green. 40 over x is equal to 5 over 2. Crisscross multiply, so 5 times x is 5x. 40 times 2 is 80. Divide both sides by 5. And our x is equal to 16. All right, so bottom line is it's area over area equals scale factor squared. Okay, so we can use the scale factor, or we can use corresponding sides to determine the scale factor, and then we can use the scale factor to find missing areas. If we're given both areas, we can use those areas to find the scale factor, and then use the scale factor to find missing side lengths. All right, so does anybody have any questions on either of those topics. All right, then your practice for today is on page 821. One through 4, and then 6 through 13.